We are live. So lesson 7 then.
Turn straight.
Okay, so number
So
4
part
first then, right?
What was that, Nico?
Number 4 first.
Yes, unless, did anyone have any questions on part 1? Or should we just jump in and...
No, sorry, it's really quiet, so I have to hold it up to my ear.
Oh,
I'm sorry, it looks so weird.
okay. Number 4 then.
Do your kids have headphones like that? Hecho? An act or means done. It depends on the context, but it means
The
what?
sample size
Yeah, well done.
n equals 4 are taken from normally distributed 2011 sales data. What is the shape of the distribution of X? Or
Well, it says
That
right
one,
in the...
would you?
I know that Elder Brookdorf said that
it says right in it that it's normally
Yeah,
distributed.
it is. In the description, it says it's normally distributed, so that it would be normal.
thought that I was going to speak in German
And
today.
it's normal because the parent population. Yeah.
Right.
So question 5, sample size of n equals 40 are taken from the normally distributed 2011 sales data. What is the shape of distribution of X? Well, that would be normally too, right?
Yeah, because it's a large sample size, and it's still from the same
Normal as well, yeah.
normal.
Sample size
Yep.
n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X is less than 40? So wouldn't we need to find out the z-score for that?
Yes.
And then do we have to plug it into that applet?
Not...
Just had to find out the z-score.
I don't think we have
But
to
if
put it
you
into
find
that.
out the z-score, then you put that in there, and then it gives you the probability or percent.
Oh yeah.
Okay.
Yeah. So I don't know that you'd put it in the applet just yet. You'd have to find the z-score first.
Okay.
No, I think we do put it in.
Put what into the
The
applet?
I think you put the z-score in, because the z-score should be -1,
Yeah.
but that's not.
Put that into the applet to find out the.
Yeah, but that's not the actual answer. That's just the first step.
Because the z-score goes in the applet, so you have to find the z-score to know what to put in it.
Yes.
But
Yeah.
Do
what is the other?
you remember the formula for that, Vanessa?
X bar minus mu divided by standard deviation divided by the square root of n.
Yeah. So for this one, it would be 40, because that's the observed, the less than 40. 40 minus 45.
I'll take your word for it because it doesn't finish the document on the one I'm looking at. So I don't have the numbers.
Oh, you don't have the numbers?
I don't.
Oh.
So I just have to believe you. I know what you're doing though.
Yeah, so it's 40 minus 45 because the mean is 45. And then the standard deviation is 10. And our number is 4. So
The square root of 4?
square root of 4.
Go
10 divided by the square root of 4.
Okay.
which gives you -1. Is that what everyone else got?
That's what I got.
That would be correct.
Two.
So then when you plug it in, you get 0.1587.
If we pass in Publix again, then yeah.
1 point roughly.
We'll pass some stores on the way tomorrow too.
You got that sourdough bread, which you can make.
That's true. Yeah, we haven't ever sliced that up.
We
We
still
still
slice that up and
Okay, are we good on that one?
I'm good.
Yeah, I got 158.
Yeah, we can
Okay.
brownies you guys haven't touched.
So number 7, a sample size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed x is greater than 35 and less than 55? So for this one, you have to figure out the z-score using the 35 in the equation and the 55 in the equation.
You should be
Yeah.
able to put the -1 into the applet, and then it should just be able to show you.
Yeah.
Look at the applet and see the percentage.
To put -1 in?
Yeah.
Where'd you get -1?
Because we did that on the other problem. If the numbers stay the same, then your z-score should be the same, and you should be able to plug that into your applet and get the answer.
I was just saying, what's your
It's not, they're not all the same though. For
But
this
if you put
next one.
35 in the applet, wouldn't it give you the z-score?
Yeah, you should be able to do it that way. I mean, one way or another, you have to get the z-score for the 35 and the 55.
Oh, does it give you a range? You have to.
Yeah,
Oh.
greater
okay.
than 35 and less than 55?
I'm not saying that's culture. Oh yeah.
So the z-score on that one is at -2. That's what I got. Is that
Yeah.
right?
Well, for the 35, it's -2. Got the one. And then the 55, it's 2.
Miami State or something. It's gonna be
So I watched the tutor
Right.
video for this one, and he pointed out, I mean, because it's the standard deviation of 2, then it fits in the 68, what's the rule? 95, yeah, it's the 95, basically you could look at it and know that's the 95th percentile.
Yeah.
check out and look up for more like that.
But if you put them in, then you get 0.9545.
That's what I got.
And then 8 is a similar thing, just with different numbers.
So we would have to do the square root of 25 versus the square root of 4 that we've normally
Right.
been doing.
Yeah, so your number is different, and then your range is different also. It's between 41 and 49.
Okay.
But it's
I got -2 and 2.
yeah, it's the same
That's the same as
end result.
7,
So then the probability would also be 0.95.
Yeah.
45.
So question 9, a sample size of n equals 25 is taken from the normally distributed sales. What is the probability that the observed x is greater than 50?
So I got a z-score of 2.5.
Which one, 9?
That's the answer. Why is that?
Oh, just-
So yeah, 0.0062
That's what I got.
That's what I'm seeing.
Yeah.
Agreed.
Square root of 25.
So question 10, sample size n equals 4, taken from the right skewed data. What is the shape of the distribution of x? That'd be right skewed,
Yeah.
because it's a small
Yeah.
sample size.
Yep.
So a sample size of n equals 40, right,
Skewed.
Normal.
So it's,
would be normal.
yeah.
They're saying at the Math Tutoring Center that anything over 30.
That's what it said in our book. Yeah.
Is there a theorem that justifies your answer to question 11? What is the name of the theorem?
Central limit theorem.
Yeah.
Which is as the sample size gets larger, then the distribution becomes closer to normal. That's the central limit theorem.
Yes.
Okay.
A sample size of n equals 4. Did you guys just do that one?
No, we're still talking about 12.
Oh.
We haven't. No, go ahead.
Can you compute this probability using the normal probability applet with the information you have? Why?
It says it's right skewed, so it's already implying that it's not normal.
Right, so you couldn't use the
you-
applet
You
because
can't use it because it's a normal probability applet, right?
yeah. A sample size of n equals 36 is taken from the right skewed data. What is the probability that the observed x is greater than 36.5?
So it would be the same setup that we did for the other equations previously to find the z-score.
Yeah.
So that's 36 point.
Yeah, 36.5 minus, where's the numbers? Minus 40.
Divided by 2.
Yes, 40 divided by 12.
Divided by 12.
Divided 12 and divided by the square root of 36.
I got the z-score of negative 1.75.
Yeah, me too.
And then the probability would be 0.6.
And then the probability is 0.9599.
Yeah.
That's what I got. So then 15, a sample size of n equals 36 is taken from the right skewed data. What is the probability that the observed x bar is between 37.5 and 42.5?
They'd have to find out the z-score for each one.
Yeah.
So negative 1.25 and 1.25.
Yeah.
Then the probability is 0.1056 for each of those. So then wouldn't you have to subtract that from 1 to get the total probability?
Don't you just put the z-score in the
Oh yeah, you could
applet?
yeah, and then we would select just what's in the center.
Right, because we want what's between the two.
Yeah.
So I got 0.7887.
Yeah. That's what I got.
All right, so I'm going to stop broadcast then. We did the last one of that, right?
Yeah.
Okay.